Ever wondered how the internet finds the most efficient route to deliver your data? The answer lies in a protocol called BGP, or Border Gateway Protocol. In the vast digital expanse of the internet, with its multitude of networks, comes the need for a protocol to manage how data gets from one point to another. That's where the Border Gateway Protocol, known as BGP, steps in. It's like the postman of the internet, making sure your data, or packets, to use the technical term, get to where they're supposed to go. BGP is a path vector protocol that maintains a table of IP networks, or prefixes, which designate network reachability among autonomous systems, AS. Think of these autonomous systems as individual neighborhoods on the internet. BGP is the protocol that makes sure your data doesn't get lost on its way. Now, BGP isn't just a delivery guy, it's more like a delivery guy with a highly sophisticated GPS. It doesn't just know the route, it knows the best route. It's responsible for making sure that your data takes the most efficient path from its source to its destination. But BGP isn't just about efficiency, it's also about flexibility. It can handle routing on the grand scale of the internet with its millions of routes. It's also able to adapt to the ever-changing landscape of the internet, where routes can change in a blink of an eye. BGP plays a crucial role in interconnecting different networks on the internet. It's the glue that holds the internet together, making sure that every part of the internet can talk to every other part. Without BGP, the internet as we know it wouldn't exist. BGP is more than just a protocol, it's the lifeblood of the internet. It's the unsung hero that works behind the scenes, making sure that your data gets to where it needs to go. So, the next time you're streaming a video, sending an email, or just browsing the web, spare a thought for BGP. It's working hard to make sure your data gets to you as efficiently as possible. Now that we've laid the foundation of what BGP is, let's delve deeper into how it works. So, how does BGP manage to route your data effectively across the internet? Well, let's dive right in. BGP, or Border Gateway Protocol, is like the postal service of the internet. It doesn't deliver the letters or packets itself, but it does tell them where to go. It does this by exchanging information between routers in different autonomous systems. An autonomous system, or AS, is a network or group of networks under a common administration and with common routing policies. The internet is a collection of these autonomous systems. When you want to send data from one AS to another, BGP is the protocol that steps in. Now, how does BGP exchange this information? It uses something called TCP, or Transmission Control Protocol, as its transport protocol. TCP is reliable, meaning it ensures that data reaches its destination without any errors. It's like the trusty mail carrier who ensures that your letters get delivered to the correct address. But BGP doesn't share information with all routers, only with its neighbors. BGP neighbors, also known as peers, are routers that have established a TCP connection for exchanging BGP routing information. This connection is established manually by an administrator. Once the connection is up and running, the BGP neighbors can start sharing routing information. What's interesting is that BGP doesn't care about the shortest path. It's more concerned with policy. That's why it's known as a path vector protocol. It can determine the best path based on a variety of factors and not just the distance to the destination. To sum up, BGP operates in a unique manner. It uses TCP to create reliable connections between routers in different autonomous systems. It then uses these connections to exchange routing information with its BGP neighbors. This allows it to effectively guide data across the vast expanse of the internet. With this understanding of the basic workings of BGP, we can now move on to its attributes. BGP attributes are crucial in determining the path selection process. But what exactly are these attributes? Let's dive in. Firstly, there are the well-known mandatory attributes. These are attributes that must be recognized by all BGP routers and included in every update. They include attributes like AS-path, which lists the autonomous systems that a route has passed through, and next hop, which indicates the next hop IP address to reach the destination. Then we have the well-known discretionary attributes. These are recognized by all routers, but are not required in each update. The local preference attribute falls into this category and is used to select an exit point from the local autonomous system. Next up is the optional transitive attributes. These might not be recognized by all routers, but if they are not understood, they are marked and passed along anyway. The aggregator is a prime example of this, providing information about the router that aggregated several routes into one. Lastly, we have the optional non-transitive attributes. These are not required to be recognized or passed along. A good example is the MED, or multi-exit discriminator, which suggests the preferred path into an autonomous system but does not need to be passed to other autonomous systems. Each of these attributes plays a distinct role in the path selection process. For instance, the AS-path attribute is used to avoid routing loops, with shorter paths typically preferred. The next hop attribute, on the other hand, is used to determine the next router in the path to the destination. Local preference, as another example, is a well-known discretionary attribute that can be used to influence the route selection within an autonomous system. Higher local preference values are preferred, providing another level of control in directing traffic. These attributes play a critical role in how BGP selects the best path for data transmission. Now let's see how to configure BGP. Configuring BGP might seem daunting, but with a step-by-step approach, it becomes manageable. Let's dive into the configuration process. We'll start by accessing the router's command line interface. From there, we'll enter the global configuration mode by typing configure terminal. This is the canvas where we'll paint our BGP masterpiece. The first brushstroke is the router BGP command, followed by our autonomous system number. This command announces to the world that we're configuring BGP and introduces our autonomous system to the network. Next, we need to define the neighbors. This is done with the neighbor command, followed by the IP address of the neighbor router, and then the word remote as, followed by the neighbor's autonomous system number. This creates a relationship between our router and the neighbors, allowing them to share routing information. Now, we need to advertise our network to our neighbors. The network command, followed by our network's IP address, does exactly this. This command tells our neighbors about our network, inviting them to send traffic our way. We've done a lot so far, but there's still a few more steps. We need to establish some BGP policies using route maps. These policies dictate how our router handles incoming and outgoing traffic. The route map command, followed by a map name and a permit or deny statement, allows us to create these policies. Finally, we apply these policies to our neighbors using the neighbor command again. This time, followed by the IP address of the neighbor, the word route map, the name of the route map, and the direction of traffic, either in or out. And there we have it. A step-by-step guide on how to configure BGP. It's a complex process, but once you understand the purpose of each command, it becomes much easier. And remember, like any skill, the more you practice, the better you'll become. And there you have it, a basic configuration of BGP. But remember, practice makes perfect. We've covered a lot today, so let's take a moment to recap. Today, we've delved into the intriguing world of Border Gateway Protocol, or BGP. We embarked on this journey by introducing what BGP is. It's a complex yet essential protocol used for routing between autonomous systems on the internet. This dynamic protocol plays a pivotal role in the smooth operation of the internet, allowing data to find the most efficient path from one network to another. From there, we swung the spotlight onto the mechanics of BGP. We learned how it works, how it finds the most efficient path for data transfer, and the role of autonomous systems in this process. Unlike some other protocols, BGP doesn't focus on the shortest path, but rather the most efficient one. considering a multitude of factors to make this decision. Next, we explored the fascinating realm of BGP attributes. These are the parameters that BGP uses to make routing decisions. We learned about the different types of attributes, including well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. Each of these attributes plays a unique role in influencing BGP's routing decisions, and understanding them is key to mastering the protocol. Finally, we dived into the practical side of things, looking at how to configure BGP. We learned about the various commands used to configure BGP on a router and how to verify the configuration. We also discussed the importance of configuring BGP correctly, as incorrect configurations can lead to inefficient routing or even disrupt the entire network. And that wraps up our discussion on BGP. Remember, the journey of mastering networking protocols is a marathon, not a sprint. Keep learning, keep exploring, and see you in the next video.